So at this point, we've been talking about how to solve quadratic equations by completing the square for quite a while now. And you might ask yourself, can we solve a generic quadratic equation, such as this one on the board, once and for all, using the method of completing the square? And maybe if we do that, we can derive a formula which will be able to solve every quadratic equation just by plugging numbers in. Well, the answer is yes, we can. And the formula we get is called the quadratic formula. So first off, every quadratic equation is of this form. ax squared plus bx plus c equals 0, where a, b, and c are usually integers, usually whole numbers, but they can be even real numbers in general. And if it's not of this form, then we can make it of this form. Now, how can we solve this by completing the square? First step, we want the coefficient of x squared to be 1, rather than just some arbitrary number a. So we need to multiply both sides of this equation by 1 over a. All right, so multiplying by 1 over a is the same as dividing every single term by a. So ax squared over a, well, the a's cancel, and that just leaves us x squared. Bx over a is exactly that, just bx over a. And c times 1 over a is just c over a. Well, 0 times anything is itself, so 0 times 1 over a is equivalent to 0 over a, which is just 0. All right, what's the next step? Well, we need to move the constant term, which is the thing without an x or an x squared, to the other side. So we need to move this to the other side. And we know that when we do that, we change the sign. So we get x squared plus bx over a is negative c over a. Okay, what's after this step in completing the square? Well, we have to look at the coefficient of x. Okay? So the coefficient of x is everything in this term other than the x itself. So in this case, it's b over a. And we're going to do some computation involving this coefficient, off in a little thought bubble off to the side. We'll draw our thoughts over here. And I'm also going to put a plus blank on both sides of the equation, because the goal, of course, is to fill in that blank. Plus blank equals negative c over a plus blank. All right, the thought bubble. So, do you remember what we do when we complete the square? Well, we take this coefficient, b over a, and we divide by 2. Now, dividing by 2 is the same as multiplying by 1/2. So this equals b over a times 1/2. And we can multiply across, because these are two fractions. So b times 1 is b, and a times 2 is 2a. So we get b over 2a. Now, is this what we put in the blank on both sides? Not quite. So with completing the square, there's one more step in this thought bubble. We have to square this guy. So take b over 2a, and we square it. Well, what's that? That looks really confusing. Just remember, when you square something, you multiply it by itself. So this just means b over 2a times b over 2a. And we can multiply across again. So b times b is b squared. What about 2a times 2a? Well, 2 times 2 is 4, and a times a is a squared. So we get b squared over 4a squared, and that's what we put in the blank on both sides. Okay. Now the point of doing that is that, as always with completing the square, this left side will now be the perfect square of a binomial. Which binomial? Well, it's always x plus this thing right here. So it's x plus b over 2a quantity squared. And as always, if we FOILed this out and simplified, we would get the left side. What about the right side? Well, to add these guys together, we need a common denominator. So to get that, we need to multiply the first term by something over itself. When we multiply is whatever it's missing in the second term, right? Because a goes into 4a squared, but what is it missing? Well, it's missing another multiple of 4a. If I multiplied 4a times a, I would get this 4a squared here. So I need to multiply by 4a over 4a. Now the point is we're always really multiplying by 1 to not change anything. And anything over itself is 1. So we're not changing the values, and therefore we're not unbalancing the equation here. Okay, so we can multiply across. 4a times negative c is negative 4ac. You can write it negative 4ca as well, but usually we like to do alphabetical order. And then a times 4a is 4a squared. That was the point of this whole thing. So we have negative 4ac over 4a squared plus b squared over 4a squared. And now that we have this common denominator, we can combine both those fractions together. We can write both of them over the same denominator. So upstairs we'll have negative 4ac plus b squared, but it's more traditional to write that the other way around. B squared minus 4ac. And downstairs, of course, we have the same denominator, 4a squared. So we have x plus b over 2a quantity squared equals b squared minus 4ac over the quantity 4a squared. What's next? Well, we want to take the square root of both sides. Take the square root here and the square root here. Now remember, on the right, we always put a plus or minus as well. On the left, the square root and the square, they'll just cancel each other out. So what we have is x plus b over 2a equals plus or minus square root of the quantity b squared minus 4ac over 4a squared. Let me take a moment to write this up top and erase everything. Okay, so this is what we have so far. This is the equation we were trying to solve. Ax squared plus bx plus c equals 0. And we got to this step so far. X plus b over 2a is plus or minus the square root. Now, a square root distributes over division and multiplication. It does not distribute over addition and subtraction. But here we have division. So in other words, the square root of this quotient is the same as the quotient of square roots. So this is the same as plus or minus square root b squared minus 4ac over the square root of 4a squared. So we have x plus b over 2a equals this. Okay, so what is the square root of 4a squared? Well, again, the square root distributes over this multiplication here. So the square root of 4a squared is the same as the square root of 4 times the square root of a squared. And this denominator is just the square root of 4 times the square root of a squared. Now the square root of 4 is 2, and the square root of a squared is basically a. So let's rewrite this one more time. The numerator stays the same. And we get 2 times a. Again, the square root of 4 is 2. The square root of a squared is a. Now you might object, and this is a very subtle point, the square root of a squared is actually the absolute value of a, the positive part of a. And while this is true, we already have a plus or minus in front. So we're going to get both signs anyway. So we can just write a here. So we have x plus b over 2a equals this quantity. The very, second to last step is we move this term to the other side. And of course, we flip the sign. So x is negative b over 2a plus or minus that quantity. The square root of b squared minus 4ac over 2a. And since these two terms have the same denominator, we can write it as one fraction. Negative b plus or minus square root b squared minus 4ac all over 2a. And this is our quadratic formula.